Our first video that you're going to look at home is going to be how to solve equations. The purpose of solving equations is to solve an equation and determine the value of a variable that makes the statement true. So what this means, if we're looking at the equation x plus 2 equals 10, and we need to solve the variable, that means we need to solve for x. What is x equal to in order to make the statement true? For the statement to be true, our left side has to equal our right side. So what we're asking ourselves is, what is x plus 2 so that the value of it is 10? So at a glance and at a guess, you can probably see that this x needs to be equal to 8, because 8 plus 2 equals 10. If we wanted to show our work though, when you're solving equations, you always do the opposite operation. So the opposite of addition is subtraction, and you make sure whatever you do to one side, you do to the other side as well. So if I'm going to subtract 2 from my left side, I always have to subtract 2 from my right side as well. So we have isolated for the variable, which means we've got an x all by itself, because 2 minus 2 equals 0, and those cancel out. 10 minus 2 is equal to 8. So we've just proven our work mathematically that x is actually equal to 8. Let's look at another example to show that as well. If we had x minus 2 is equal to 12, we do it the exact same way using opposite operation, and what you do to one side you do to the other. So the operation this time, when we want to remove that negative 2, we would add 2 to the left side so that those cancel out. If I'm going to add 2 to my left side, I need to add it to my right side as well. Therefore, leaving me with x equals 14. So there are other questions that you're going to need to solve where you have to do more than just the operations addition and subtraction. You're going to have to incorporate multiplication and division as well. So our next example is 2x minus 3 equals negative 15. So we want to work opposite now of our BEDMAS rule, thinking of your addition and subtraction first, and then multiplication and division. So when I solve this question, my 2x stays untouched at first, and I'm going to remove my negative 3. So negative 3 plus 3 is equal to negative 15, and I have to add the 3 to this side as well. What you do to one side, you do to the other. Eventually this step here, with more practice, will not be necessary. So I'm left with 2x, these cancel out, is equal to negative 15 plus 3, which is negative 12. Here, this 2x, this 2 attached to the x, please remember that that is multiplication. So 2 multiplied by x equals negative 12. So the opposite of multiplication is division. So if I divide my left side by 2, my 2's will cancel out because 2 divided by 2 equals 1. And what you do to one side, you do to the other. Negative 12 divided by 2. So we cancel out our 2's, and that means we've isolated for x. And then negative 12 divided by 2 is equal to negative 6. At this point here, we can check our work to be sure that we've done it correctly. I'm just going to rewrite the question, break it up a little bit. 2x minus 3 is equal to 15. So I've broken it up by left side and right side. If I've solved my question properly and I substitute negative 6 back into the x here, my left side should equal negative 15, as it said in the original question. So 2 multiplied by negative 6 minus 3. 2 times negative 6 is negative 12 minus 3, which does equal negative 15. So therefore, I've done the question correctly because my left side is now equal to my right side. I have made the statement true. Our one last example that we're going to look at here is going to be x divided by 3, x over 3, is equal to negative 4. So in order to solve that, we have to first look at our x divided by 3 and realize that operation is division. The opposite of division is multiplication. So in order to isolate for x, I need to multiply my left side by 3. And then if I'm going to multiply my left side by 3, I must multiply my right side by 3. I chose 3 because I know that 3 divided by 3 is equal to 1. Therefore, those will cancel out. So the denominator will always be what you multiply the left and right side by. So this leaves me with x equals negative 12. Again, I can check my work here. My left side was x divided by 3, and my right side was negative 4. So if I've decided that x is equal to negative 12, and I substitute that in to x, I can see that my left side is going to equal my right side, therefore proving that scenario true. At this time, I'm going to leave you with a couple examples to try, and then we'll look at them at the beginning of class tomorrow and see how you did. The first example that you would like to be able to solve for is 3x minus 2 equals 10. That's our first example. Our second example that we would like you to try is x divided by 2 plus 1 equals 11.